Flames have engulfed a large part of the western U.S. this year. The total acreage burned by the wildfires is the sixth highest in the past 40 years, and the year is not over yet. Wildfires don't just incinerate thousands of acres, they can also produce their own weather. Fire-induced thunderstorms towering over cities, raging fire whirls dancing across landscapes. These phenomena make fires more dangerous and grasp the attention of the public. But many do not know about the science behind these devastating forces of nature. Wildfires can create their own clouds and even thunderstorms as heated air rises and the moisture in the air condenses. Typically, the clouds produced by wildfires are classified as pyrocumulus and pyrocumulonimbus. The pyro prefix in front of the cloud type indicates that they are fire-induced.
Pyrocumulonimbus clouds are associated with very large wildfires, and they differ from your generic pyroQ. You can have a very small fire that generates a small cumulus cloud on top of the smoke plume. And those are fairly benign, like any fair weather cumulus.
For a pyrocumulonimbus cloud to form, there needs to be instability in the atmosphere. This comes from mid-level moisture and the heat released from the wildfires, which forces the air to rise vertically. As the air rises, water vapor condenses and forms into water droplets, which leads to the formation of the cloud. Pyrocumulonimbus clouds reach high into the atmosphere and have ice crystals in them that collide due to upward motions. Electrical charges result from the collisions, and eventually the built-up charge gets released as lightning. As with any thunderstorm, there are hazards, but fire-induced ones bring extra threats with them. Lightning can possibly spark new fires from the strikes that contact the ground. Pyrocumulonimbus clouds can produce rain, which evaporates into the air and cools it. This chilled air can accelerate downward, creating what's known as a downdraft. Downdrafts can push fire fronts in different directions, which makes it dangerous for anyone in the fire's path. Embers from fires can also be carried miles away by these strong winds, and can result in new fires forming. This is known as spotting. In addition, some downdrafts can produce winds of over 100 miles per hour, which can also be very damaging. Phenomena known as fire whirls and fire tornadoes can also develop from fires.
Fire tornadoes or fire whirls, so we try to distinct in the fire behavior community the difference between a fire tornado, which is really something that's been generated by a pyrocumulonimbus, versus your everyday fire whirl. Fire whirls happen all the time. They're just about every fire will have a fire whirl. So when you see, the media saying, "Oh, there's a fire whirl in this fire," it's like, yeah, of course there is, because how do dust devils form? And maybe but you got horizontal wind shear, you have vertical motion from the heat, and so you can tilt.
Typically, fire whirls only last a few minutes and are on average a couple hundred feet tall. Fire whirls usually have winds of 30 to 40 miles per hour, but can be very destructive with their fast forward speed and their ability to rapidly spread fire. Fire tornadoes are extremely rare and get rated on the EF scale, unlike fire whirls. Most fire tornadoes have been rated an EF0 to an EF1 with winds upwards of 110 miles per hour. In 2018, the Carr Fire produced a fire tornado that was the strongest in recorded history and was rated an EF3 with winds of 143 miles per hour. Dr. Craig Clements, professor of meteorology and director of the Fire Weather Research Laboratory at San Jose State University, was one of the meteorologists who surveyed the fire tornado's damage.
California has now the record of fire tornadoes with the Carr Fire, which was an EF3. And my team of students and I were invited by the Forest Service to go do an initial field analysis damage survey of that. And the things that we saw, you may have seen the picture of the pipe wrapped around the tree. It was a gas line that was wrapped around a tree. All the bark on the trees were scoured and removed from sandblasting, and just major power lines dropped down. So they estimated that as an EF3.
On August 15, 2020, the first ever fire tornado warning was issued by the National Weather Service for a fire tornado produced by the Loyalton Fire in northeastern California. This fire tornado was rated an EF1. In fire meteorology, there are still so many questions that need answers. Dr. Clements and his research team have been focusing on the science behind wildfires and its environment for the past 10 years. A part of this research involves taking various plant samples to gauge their moisture content, which determines how flammable they are. This data then gets put into a national fire danger rating database. Moisture content is one of the many environmental conditions that the team studies.
kind of what we're looking at is how to better understand the onset of downslope windstorms in not steep topography, but maybe local terrain, and how that affects fire behavior. A big question in California and the Western U.S. is public power shutoffs, public safety power shutoffs, so PSPSs. These are de-energizing events that are conducted by utilities. And so having a better handle on that is a current research topic.
Over the years, researchers have attained a solid understanding of pyrocumulonimbus clouds, but still know very little about fire whirls and fire tornadoes. Part of this is due to the lack of resources made available to them. These phenomena are also associated with fire, which makes them difficult to study. Hurricane specialists have recon planes to gather data, and severe weather specialists have mobile radar networks. Fire weather specialists only have a Doppler radar and LiDAR. New imagery technology is coming out soon that should help researchers like Dr. Clements unravel more mysteries associated with extreme fire phenomena. For Weather World, I'm Nick Guzzo.